Imagine standing on Earth looking up at the sun. It feels enormous, powerful, like nothing could possibly be bigger. You would be wrong. There are stars out there so unimaginably large that if you placed one where our sun sits right now, it would swallow Mercury, Venus, Earth, Mars, and keep going. Past Jupiter, past Saturn, almost to the edge of our solar system. So what is the largest star we have ever found? And how does something that big even exist? Let us start with what we know. Our sun has a diameter of about 1.4 million kilometers. That sounds incredible. You could fit roughly 1 million Earths inside it. By any human standard, it is a monster. But in the context of the universe, our sun is average. Completely, almost embarrassingly average. Stars are classified by size, temperature, and luminosity. Our sun sits in the middle of the pack, a yellow dwarf, stable, reliable, unremarkable, the cosmic equivalent of a mid-sized sedan. Now, at the other end of the scale, you have something called hypergiants. These are stars so far outside the normal range that astronomers needed a new category just to describe them. They are not just big, they are big in a way that breaks your intuition entirely. When a star has many times the mass of our sun, it lives fast and dies violently. But before it dies, something strange happens. It expands. As these massive stars age, they exhaust the hydrogen in their cores and begin fusing heavier elements. The outer layers swell outward, slowly at first, then dramatically, into what we call a red supergiant. The star does not get more massive, it gets bigger, puffed out, like a balloon inflated from the inside. And this is where we start encountering scales that genuinely do not fit inside the human mind. One of the most famous red supergiants is Betelgeuse. You have probably heard of it. It sits at the shoulder of the constellation Orion, and it is roughly 700 times the diameter of our sun. 700 times. If the sun were a golf ball, Betelgeuse would be roughly 4.5 meters across. And Betelgeuse is not even close to the largest. Measuring the size of a star is genuinely difficult. They are not solid objects you can put a ruler against. Astronomers use indirect methods, measuring brightness, temperature, distance, and how the star pulses, and then calculating a probable radius. This means our rankings shift as measurement techniques improve. For years, a star called Canis Majoris held a claim near the top. Located roughly 3,900 light-years away in the constellation Canis Major, early estimates put it at nearly 2,000 times the radius of our sun. 2,000 solar radii. If you placed it at the center of our solar system, its surface would extend past Jupiter. Think about what that means. Jupiter, the planet that contains more mass than every other planet in our solar system combined, would be inside this star, not orbiting it. Inside it, but more recent measurements have revised Canis Majoris downward somewhat, and newer contenders have emerged. Right now, one of the strongest candidates for the title of largest known star is Scuti. It sits about 9,500 light-years away in the constellation Scutum. It was catalogued back in the 1860s by astronomers at the Bonn Observatory, but its true scale was not appreciated until much later. Scuti has an estimated radius of around 1,700 times that of our sun, though some estimates push higher. Let that breathe for a moment. 1,700 solar radii. If you were to drive a car around the equator of Scuti, at highway speed without stopping, it would take you roughly 2,000 years to complete one lap. Light itself, traveling at 300,000 kilometers per second, would take around 6 hours just to travel from one side of the star to the other. Our sun? Light crosses it in about 4 seconds. This is the part where the brain quietly gives up trying to picture it and simply accepts the number as an abstraction. That is normal. These scales are not built for human intuition. Here is a question worth asking. Why does Scuti exist at all? What process produces something so extreme? It comes down to the life cycle of the most massive stars. When a star begins its life with somewhere between 10 and 40 times the mass of our sun, it burns intensely hot and fast. These stars live for only a few million years, a cosmic eye blink compared to our sun's 10 billion-year lifespan. As they age, the balance between gravity pulling inward and radiation pressure pushing outward starts to shift. The core contracts while the outer layers expand dramatically over hundreds of thousands of years into that bloated red hypergiant state. Scuti is likely in this late phase. It is not stable. It pulses. Its diameter actually changes over time as the outer atmosphere heaves in and out. It is also shedding mass at an extraordinary rate. A stellar wind strips material from its surface and flings it into space, forming a vast nebula around the star. Scuti is slowly and constantly falling apart, and when it finally goes, when the core can no longer hold, it will collapse and explode in a supernova. What remains will likely be a neutron star or possibly a black hole, all of that volume compressed down to an object perhaps 20 kilometers across. From something that dwarfs our entire solar system to an object you could fit inside a city. Here is something important to say directly. We do not know for certain that Scuti is the largest star. The universe is vast. Our telescopes have limits. Stars obscured by dust clouds or sitting in distant galaxies may be larger than anything we have catalogued. And measurement uncertainty matters here. The estimated sizes of these hypergiants carry real error bars, margins that can shift rankings significantly as our instruments and methods improve. What we can say is this: Scuti represents the outer edge of what we currently know. It may be dethroned tomorrow by a new observation. That is how science works. The answer today is the best answer we have today. There may be stars out there, right now, that make Scuti look like our sun looks to us. So, what is the largest star in the universe? The honest answer is, we do not know. The universe is too large, and our view of it is too limited to be certain. But the largest star we have found, the one currently at the top of our catalogue, is likely Scuti, a red hypergiant sitting nearly 10,000 light-years away, pulsing and shedding and slowly dying, with a radius roughly 1,700 times that of our Sun. If you replaced our Sun with Scuti, you would no longer have a solar system. You would have a star. We think of the Sun as the immovable center of everything we know, the anchor of our world. And compared to Scuti, it is a spark. That is not a reason to feel small. It is a reason to feel something rarer. Perspective. The universe does not hand out that kind of perspective easily, but when it does, when you truly sit with the scale of something like this, it changes how you see the sky. Next time you look up and find Orion, find that reddish star at his shoulder. That is Betelgeuse, 700 times the size of our Sun, and somewhere beyond it, too faint to see with the naked eye, Scuti is out there, pulsing, enormous, and quietly waiting to die. If you want more of that feeling, more questions that pull the floor out from under you, subscribe. There is a lot more universe left to explore. Next time, we are asking a question that goes even further back. What existed before the Big Bang? And does that question even make sense?